Hi, my name is Oliver Miller, and I'm an undergraduate here at UAlbany in the Environmental Science program, and I'm doing a presentation today on predicting Lyme disease risk using the New York State Mesonet systems. This research comes after about a year of work. The Ixodes scapularis, or black-legged tick, is the most common vector for Lyme disease all over the United States, but most cases of Lyme disease happen in the Northeast, so that is where our research was focused. Lyme disease is caused by the pathogen Borrelia burgdorferi, and the disease itself is called Lyme disease. It's very dangerous and affects tons of people each year. We're looking at microclimate specifically using this because ticks tend to hide under dried leaf litter, and the climate under the dried leaf litter is very different than the climate that is on top. So when we're looking at tick activity, we do that. Our whole goal was to develop a risk assessment profile for Lyme disease using the already in place Mesonet infrastructure. And to do that, we set up weather stations in order to look at microclimate to predict tick activity better. You can see right here are 4 sites outlined in red. We had one at Ballston Spa, one in Duanesburg, one in Schodack, and one in Voorheesville. And those sites were in close proximity to Mesonet sites, but not on top. This is our logger right here. We had 3 of these at each site rotated. High level one was at 2 meters, the middle one at 1 meter, and the bottom one at 0.2 meters. The bottom one is the most important one, as that was the closest to the microclimate we were looking at. And as you can see right here, this goes from 615 to 809 most of the time that we were doing sampling and had the weather stations up pretty consistently. The gap here is we didn't have enough loggers to cover the whole site. So we were tracking relative humidity and temperature in 5-minute intervals, and we'd have these loggers on rotation from different sites to different sites on occasion. And you can see here's an example of June 26, 2020 at Schodack Island. You can see the sites are striated where the Schodack Island follows a curve, and they follow the similar curve, but they're not fully correlated. They don't follow it exactly each site. They all vary in their own sense. So our goal was to run correlation analysis on it. And the threshold right here at 82% relative humidity is an agreed upon threshold using a good deal of literature that decides that 82% relative humidity is typically the relative humidity, microclimate-wise, in which black-legged ticks stop doing much activity. Now, in most of these cases here, all of the cases really, the closest site that we had, the closest Mesonet site to our weather site was not the strongest correlation at any point. It had a very strong correlation, as you can see here, 0.951 to 941, but the 0.951 to Schodack was still higher than the 0.941 to Voorheesville, which was the closest. So at each site, the closest site to it weren't there. So there has to be issues with local and regional weathers and climate systems to explain this, although our correlations are still very good. Now, as you can see here, we use the Ward's 1963 clustering criterion. And here's a graph of it right there using the relative humidity. And by doing that, we were able to put the temperatures and relative humidities that were closely correlated with each other into these subgroups. And we were able to divide New York State into different regions, all of these dots being specific Mesonet sites. So you can see which sites are more correlated to which sites, giving us a better view of how local and regional temperatures and topographies affect the environment for ticks and affect microclimate specifically. And you can see here too is this temperature. 4 clusters, how this looks versus 6 clusters. And a larger amount of clusters that we did for this allowed for a better look at regional and local differences between our Mesonet sites. Now, through this research, we discovered that New York Mesonet absolutely is an excellent tool for looking at localized weather and topography in a region. In the future, our goal is to look at solar radiation and elevation to look at differences. And this is because we believe that solar radiation and elevation are 2 big concerns or big factors as to why local/regional data is different than ours and different than the Mesonet, and why these Mesonets are grouped this way. We think a lot of it has to do with the amount of solar radiation and elevation that these sites get. Typically in open fields, some may get more than others, some may be higher up than others, and it may affect the temperature. Our high correlations do show that to some extent, the Mesonet data can be used to predict microclimate and tick activity for sure. And in the future, we're going to continue doing that. Our next steps are to use this Mesonet data as a way to work towards predictions of microclimate, as well as a risk assessment profile for Lyme disease using Mesonet as a basis. And this is in the future, we look to do this, use this Mesonet and create a risk assessment profile using Mesonet by figuring out more correlations and looking at solar radiation, elevation, more factors as to why they are different. And I'd like to acknowledge my co-authors on this, Professor Oliver Ellis and Tim, Alexander Kyle, Tasneem Ahmed, Sumer Hart. I'd like to thank New York State Mesonet and the New York State Department of Health